I am going to introduce Wayne Sarasua. He has been on the faculty at Clemson University since 1998. Before coming to Clemson, he was a faculty member at Georgia Tech for 6 years. He has worked on a variety of research projects funded by numerous entities, including the project he will be discussing today, which was funded by the South Carolina Department of Transportation. He is also involved in the Clemson football traffic study, which he recently presented at the SCDOT annual meeting. Wayne was also the recipient of the 2016 Wilbur S. Smith Distinguished Transportation Educator Award from ITE. He has a wife and 4 amazing children at 4 different schools, including Clemson, Auburn, Daniel High School, and R.C. Edwards Middle School. And I'm going to turn this over to Wayne.
Anyway, so this research that I'm talking about, it actually received an award this year from AASHTO as one of the high-value research projects from around the country. I think there was like several nominated, and I think 18 won different awards. And so I actually showed this at a poster session this year, as well as presenting it on it last year. This year's poster session was the AASHTO high-value research projects. Also want to give a shout out to Suraj, if he's there, Pamalapati, I remember his name. He was a student of mine, and now he works for Florida DOT. And Gary, he forwarded me your invite to the seminar, and so that's why I saw. And so thanks for the kind words about me. Definitely, probably nicer than they should be, but that's great.
And Suraj is a great benefit to our Central Florida office too, and he's already helped me out a number of times. Awesome. Well,
he was great here. Okay, just want to talk about the overall goal of this project is to make access management, bring it to the forefront of what SCDOT does when it considers curb cuts and permits. We want to make it safer. Literature review. Literature review kind of falls into different categories: impacts on safety, impacts on traffic operations, and of course impacts on residents and businesses. Just want to show a couple of highlights. This is very wordy, but I'm just going to talk about the conclusion. If you reduce access point density, you will likely reduce the amount of crashes you have and also improve operations. And this is from the literature. So there's been a number of studies, including Florida. Medians have been, there's an NCHRP project that identified that there are about 70% of left turn crashes occur at driveways, or driveway crashes, 70% of them are left turns. There you go. Raised medians reduce crash frequency and severity, and also improve traffic operations. There's also been, there's this myth about economic impacts because of raised medians, and so we hired Mythbusters to take a look at this, and studies have shown that perceptions typically appear worse than reality. I think those types of businesses that have a lot more passerby trips may be affected more than those that have direct generation. And so, in general, though, this myth is busted. And in some cases, after a good streetscape project that includes medians, you might get more economic activity. I want to talk about data collection. Actually, before I do this, I want to quickly, and I was going to pause my screen, but I'm just going to jump away, and I want to show you something. The presentation I've been showing you was from last year. I also gave a presentation this year, and I just wanted to very briefly show you a few things from my presentation this year. And because Gary was mentioning that there might be some interest, and it looks at right in, right out driveways, and specifically compliance issues. And we did a case study. I'm skipping a bunch of slides, but we did a case study at a brand new Bojangles, in Anderson, South Carolina. It all started when I went to the doctor's to get a mole removed, and I was sitting in the parking lot watching the activity in the Bojangles, the brand new Bojangles next door, and I was amazed about the number of uncompliant or illegal maneuvers into and out of this driveway, which is supposed to be a right-in, right-out driveway. And this is the right-in, right-out driveway I'm talking about right here. And this is near an intersection. And so, just kind of it was surprising to me that something so close to an intersection where folks can easily make a left turn here and into this full access driveway, but instead they prefer to do this and make illegal maneuvers. And we have, just a review of design. It meets all the standards from the standpoint of MUTCD and our ARMS, which is our Accident Management Guidelines here in South Carolina, and also ASHTO with regard to island size, the widths here, the signage, the offsets. And so even a good design with a pork chop island may not be good enough to eliminate or even have a great effect on illegal maneuvers. And so we did some data collection, and we used these small action cameras, and this is actually a telescoping paint pole that we bought at Lowe's. And we put it up, and you could pan it simply by twisting it. And we use Wi-Fi to see what it's, to be able to see what it's recording. We use this to collect data and just really, whoopsie, the pointer. Hold on. Oh, shoot. Just want to briefly show the maneuvers. And there's a left turn maneuver, a right turn maneuver. So I talked to a friend at the DOT and Access Management there, and I said, hey, I'd like to do a before and after study if we put in longitudinal barrier, bollards basically, at this intersection. Would you help me with this? And he was saying sure. And so we did the before study, and then they went out and did the DOT installed bollards, and then we did three days of after data collection. And so here's our bollards. This is a very simple configuration here. I know down in Florida, I think a quick curb is popular in many locations. This is a cheaper system, but these ones are easily knocked away. But what we saw was before the bollards were installed, we had like nearly 20% of non-compliance, and it reduced quite a bit after the bollards were installed. This is in a morning peak period. We also did a lunchtime peak, and again we found very similar. We got inbound 20% non-compliance that went down a lot afterwards. We were interested in total volumes too. That's why we collected data at both driveways, and we saw that there was very little volume impact, and actually volume, and for the most part, went up a few weeks. It depends on the day of the week. And so from an economic impact, when considering just volumes, there was really no difference. We did have some illegal maneuvers afterwards. This was considered a legal maneuver. U-turn across the double yellow. And then we had three-point turns. We've had other things too, like vehicles traveling the wrong way here to make the left turn in. Not recommended. So I just wanted to quickly show you this study, and there's all sorts of data associated with this that we presented at TRB this year. I want to go back now to what we were doing on this other study, which has some related slides. Oopsie. So we collected data along several corridors, 30 corridors in fact. We identified the corridors with the highest driveway crash rate according to a junction type driveway in the crash reports here in South Carolina. And so we identified 30 of them, and then I want to talk a little bit about crashes, the way we've collected crashes. Once upon a time, we used distance to intersection, and then we migrated to a GPS system, that was used for a number of years and is still used by many jurisdictions, but no longer by the Highway Patrol. But the way it worked was officers would use the handheld GPS, get coordinates, and then transfer the coordinate data to the crash reports. But we've been finding that the officers had a lot of different problems with the use of the GPS, and so many of South Carolina crashes occur in the Atlantic Ocean, North Carolina, probably some down in Florida, and other points unknown. In the new system that was transitioned back in 2010, actually mostly 2011, and most of the Highway Patrol in the state had it by 2012, it's a GIS-based system. The officer can look on a GIS map to see where he or she is. The GPS will actually show where the officer is, and then the officer can actually pinpoint the location on the map by clicking. Just a couple of things about the problems with handheld data and handheld GPS data that I wanted to add. There's a lot of issues, a lot of systematic issues. Officers would, transcribe longitude and latitude. They would. The city of Greenville decided to change their GPSs to state plane coordinates without telling anybody, and so all their crashes were in state plane coordinates. And again, it goes in the same database, and so it's we had to just mess with theirs and geocode them separately. And then other jurisdictions had their GPSs in decimal degrees, while others had degrees, minutes, and seconds. And it's very tough to know which one is which, because in the database it just goes in as multiple digits, and so 6 digits for degrees, minutes, and seconds. Any number greater than 6, though, in the ones and the hundredths place, we know would be decimal degrees. But it was very difficult. You really had to use that data along with intersection locations to really geocode them accurately. And then you can see there's a number of other systematic errors that we had with the GPS handheld. Percent geocoded by year, and the data actually did not improve very much. We told the DOT all about this back in 2007. We wrote a paper that was presented at TRB in 2008, and the word just did not spread real well, and so many of the systematic errors continued until the implementation of the new system. Here, showing on the left, this is a corridor, a busy corridor in Greenville, South Carolina, which is the closest big city to where I live. And here it shows that many of the crashes, now these crashes have been geocoded correctly. In other words, the officer would write down the correct coordinates. But even such, many of the crashes appear in parking lots and such, where officers would actually be filling out the report rather than on the road itself. On the right-hand side, here's the new system with the officers actually trying to pinpoint the location, and you can see the clusters that this is great for statewide type screening, cluster analysis, whereas on the left-hand side, it's very, very random. I just want to show you a couple of other slides. On the left-hand side, there appears to be very few crashes in the road, and that's 2010 data. 2014 data, it's not that there's more crashes, it's just there's less crashes in parking lots and such. This is in US 17 in Berkeley. Again, you can see that we had many crashes appear in the parking lots, just much more safer for the officers when they're filling out their reports to not be in the highway. And then they don't want to walk out there when they're collecting the GPS coordinates. I want to take a closer look at some data around the state. This is so some symbology here. 2010 is in blue, 11 is in magenta, and 12 is in Clemson orange. In Greenville, US 25 again. Just want to show, looking at crashes, we have a lot of crashes that occur next to left turn bays where vehicles are, we don't have really good corner clearance, and so a lot of vehicles are turning across the left turn bays into driveways. Greenville, South Carolina 146. This is Woodruff Road, and this right here is Hell's Kitchen. This is 385 near Greenville. This is kind of a shortcut to 26 that goes to Columbia. And you see here, we just have a whole cluster of driveways with poor corner clearance, very close to the ramp here, and we just have a whole tremendous amount of crashes. And just kind of a zoom in. Again, this is only 11 and 12 data here, and 10 data is again in the parking lots. Just moving down the road from this, where we go into shared driveway and an intersection, the crashes just seem to disappear. Again, much better corner clearance, and a busy signalized intersection, but much fewer crashes. And the crashes I'm showing here are just are a number of different junction types, including different crash types, not just driveway junction types. Greenwood, US 25. It just kind of jumped out at me that we had 2012 crash data, but not 11 and 10. I was wondering why. And taking a closer look, they recently built a Dollar General that maybe the corner clearance might not be the best. Richland, US 1. If you take a look here, you'll see that very few orange, and so much fewer 2012 crashes. And it just so happens that in the end of November, I believe, of 2011, they added a median. And they did this before they put they did it before and after, and they created this collision diagram. But by zooming in here, you can see crash type. We have 1 here, and we have 3 here. So these are angle left turns into the driveways. And so see, this is, there's so many of them, they're not even putting them on the sheet. This is the after scenario. And we have a lot more rear end crashes, but very few or none, close to 0, angle crashes after this. And so here's our before data on the left. And this is a 4-year period. And the after data, roughly a 4-year period also. And the numbers almost cut in half. And the types of crashes, very few angled. There appears to be more rear end crashes now than there were before. But overall, fewer injuries and definitely enhanced safety. Richland 176, again, a lot more orange there for some reason. And as it turns out, there was the gas station was converted to a higher turnover development gas station. So from those 30, we actually selected 11 from around the state for further analysis. And the 11 are most of the top ranked. We substituted a few to give us better spatial resolution. And so we added, but they're all in the top 14 or so. And these are the top 14 corridors with the most driveway crashes in the state. So we collected data. Actually, a lot of the data came from our road characteristics file called RIMS here in South Carolina. Segment data, driveway. We don't really have much driveway information, very little, but we do have some intersection information, or at least the intersection locations. We also, though, created a driveway database because, again, what we're talking about is crashes associated with driveways, or what our purpose is in this study. So we collected all sorts of attributes. I hired a bunch of students from high school and some undergraduates during a few summers ago to populate the databases. We gave them cheat sheets showing, okay, here's how you measure driveway spacing. And everything was done with Bing Maps, Google Earth Maps, and also Street View. And we populated this database, and we had a database of about 8,000 driveways along these corridors. We had, again, cheat sheets showing them what the skew angle was. Then after collecting all this data, we did safety analysis. And so one of the things that we wanted to do was associate crashes with driveways. Now, I know you all down there probably have junction type as well. And we do have in our crash reports a junction type that is driveway. However, the officers, it's very clear that the officers were not necessarily populating this field the same. And in many cases, they omitted populating it altogether. And so there were probably a number of driveway crashes. In fact, we were sure of it. A number of driveway crashes were omitted. So we included the driveway crashes, but also we included your rear end crashes, your angle crashes, your head-on. We removed basically fixed object crashes and single vehicle crashes from the analysis. Then what we did was we created buffers. And what we have here in South Carolina is we have a center line, but we do not have the pavement, a buffer for the pavement. So we created one using the RIMS data, which has travelway distance. And we used a GIS system that offset from the center line to create this travelway buffer. And then combined with another, we created an algorithm to create buffers around driveways. And we had right in, right out buffers that go halfway across, and they also go some distance to the left and to the right of the driveway based on another analysis we did. And then we had full access buffers that go all the way across. And so what you do is when you overlay these buffers with the crashes, okay, which is this one right here, then we're able to count and associate and count the number of crashes per driveway. This last table that I just kind of skipped through, you know, we would not have been able to do this analysis in 2010 because many of the crashes, again, would be in the parking lots and such. And so the association would not be nearly so good. And this table here kind of shows the average distance of crashes from the center line. It was much higher in 2010 than 11 and 12. So now that we have crashes associated with driveways, we can do some summary statistics. So here's just an example by crash rate by driveway class. And this is just raw numbers, straight number of crashes. There's no other context here, like, for example, ADT and other things. But it shows that, you know, the higher turnover, like fast food and gas stations, would have a much higher crash rate. This is big box over here. And then over here, single-family dwelling units, a much lower crash rate in those driveways along these corridors. Full access versus right in, right out. Full access had, in most cases, more than double the crash rate of right in, right out. And this is for different land uses, overall versus higher turnover and mid and low turnover. And now, well, that's all well and good, but to really isolate the contribution of what the right in, right out would be as compared to other things like ADT and other characteristics, we need to do a statistical analysis. And I'm going to skip over, you know, all the discussion on statistical analysis, but once you run this analysis, you get estimates, and see the negative things show that these variables are negatively correlated with crashes, and the positive numbers show that, like, for example, driveway class, the higher the classification, those are more highly correlated with crashes. So an increase in the classification, or the increase in speed, the increase in ADT is correlated with a higher number of crashes. Going from a full access to right in, right out, you can see that there is a negative correlation. Crashes would go down. Using the statistics, we can create crash modification factors. And so for those of you who are familiar with the Highway Safety Manual, there is methodology in there and online and in literature for the use of crash modification factors and crash reduction factors. And so it shows here that if you convert to right in, right out driveway, okay, that you reduce crashes by 69% at the driveway locations. Now this does not show that the change though at an intersection. So for example, right in, right driveways, there may be more U-turns and more activity at the intersections. But at the driveways themselves, the crash rate is shown to drop tremendously. There are other crash modification factors, driveway spacing. So as you increase driveway spacing, the crashes go down. Driveway width. This is kind of interesting that we found that if you increase your driveway width beyond the 24 feet, then you're not channelizing, well, crashes tend to go up. And I think this is because you're not channelizing traffic so much. And so if you let drivers do what they want, coming into a driveway, there may lead to more crashes. So channelizing channelizing drivers is probably a good idea. Other things, the number of entry lanes, it was kind of interesting that increasing the number of entry lanes from 1 to 2 actually showed that crashes would go down. And we had a lot of discussion and argument about this with DOT folks here. But, I had some thoughts about it that, well, if 2 vehicles can turn in at the same time from opposing directions, they may not conflict with each other if they have their own lanes. Also, though, if you do have 2 lanes and you're trying to make a right turn and you may have a little bit more space where you can zip in and not get rear-ended. And so there was just some ideas there. You can make your own conclusion. We just was showing the data. Crash modification functions rather than just discrete variables. As AADT goes up, crashes tended to go up. And this particular function is based on the roadway volumes that we saw in these corridors, mostly around 20,000 per day. And so this is where this function would apply. But it shows that, for example, if you increased your volume from 20,000 to 25,000, so that's an increase of 5,000, your crash modification function would show an increase of about 1.5 times, or an increase in crashes about 51%. This is a safety performance function for AADT. So again, on the very low volumes versus the higher volumes of crash, the number of crashes, annual crashes, goes up. Speed, increasing speed, and the association crash modification function. So by 5 miles per hour, you get close to a 10% increase in crashes, according to this. And then I just want to just mention a corner clearance, because corner clearance is a big thing here in South Carolina. We are very, very lenient in granting waivers to allow driveways within, say, 150 feet of driveways, where we're supposed to avoid that depending on what the volumes are. And if we look here at the corner clearance data, you see that the number of driveways between 0 and 150 feet versus 150 and 300, there's a lot more driveways, and they're not supposed to be there. They're supposed to be further away. Obviously, businesses want access to and they have the right of access to their land, but just having it on the main line can lead to safety issues. And if we show here, this is 2012 crashes, 0 to 150 feet from intersection for these very busy corridors in terms of number of crashes a number of driveway crashes per year. And then it goes down tremendously between 150 to 300 feet. And then if we look at the frequency, you can see that the frequency cuts in half, or almost a third here in US 25, but definitely goes down in most cases. There are other project components. We did a waiver analysis. We did some operational analysis and some economic analysis as well. But what came out of this, the big thing that came out of this was recommendations to SCDOT ARMS manual. This is the access management guidelines that SCDOT uses, and it's available to any developers. And so there's some sample changes. We made a bunch of recommendations for changes, and there's a bunch more. I just didn't want to go through them, But I want to just spend the last moment here talking about what we found. And the biggie is that, the standards that are out there that are, what we use here in South Carolina are very similar to national standards. We pulled them from, or they pulled them from national standards for the most part. And we just made some recommendations. So the standards aren't the problem. The problem is the waiver process. And we're very lenient on waivers. And so one of the things that the DOT wanted was facts, to bring back to the businesses and the developers to say, hey, we have data that shows, from a safety standpoint and even operational standpoint, what your business, that driveway will do. And so trying to give the DOT ammo to say no, or to say you need to redesign it. And so anyway, so that was the biggie. Other things, the driveway database that we developed was awesome. It was really big. Few states have a driveway database. Some states are getting more and more into LiDAR. Utah is crazy about updating their attribute databases every so many years, and so they do have a driveway database. But we saw that very few have any sort of data about driveways. And then precise crash data is critical to everything that we've done on this project. And now we're going to get a follow-up study to look at how South Carolina DOT can change how they screen crashes and how they identify clusters and safety using precise crash data. So we're going to take a closer look at the benefits of having precise crash data to crash analysis and how it could facilitate different types of crash analysis. The other thing is reading crash narratives to draw collision diagrams is just time consuming. And then we found that junction type, it'd be great if the officers were a little bit better trained about how to universally code junction type. What's an intersection versus what's a driveway, for example. But anyway, so we had some issues there. There's definitely different schools of thought. Other findings, medians are great in terms of lowering crash rates. Crash modification factor, will lower crashes by at least 50% is what we've seen. Right-in, right-out driveways are great because they eliminate conflict points. Again, they have can reduce crashes by more than 50%. I just want to mention though about right-in, right-out driveways. When we did our analysis for this year, we used right-in, right-out driveways from the standpoint of medians and then also other types of right-in, right-out driveways. For example, a raised pork chop island without any sort of centerline barrier or delineator, and then other types which just painted islands, some signage and things like that. And the crash rates are definitely higher for those types of right-in, right-out driveways than those that have some sort of physical barrier. And the bollards is an inexpensive way to actually act as a delineator, though they do have to be maintained. Down in Florida, though, I think you all use a lot of quick curb, and quick curb is definitely better than just simple bollards. And the maintenance is I think is probably better. Reducing access point density improves roadway capacity, yes. And then driveways within 150 feet of an intersection have nearly twice the crash frequency of driveways between 150 and 300 feet. And so get good corner clearance will definitely help your access management and your safety at driveways. Other things, better access policies results in lower number of crashes and also lowers crash severity. The waivers, we talked about waivers, they can be an issue. And then high turnover land uses, they have a much higher crash frequency. It definitely encourage shared driveways, things of that nature to help reduce the conflicts. And I leave you with a few images. These are images I used at TRB this year. This was the Wednesday again. Right after the game, supposedly the lights at the Empire State Building went orange, Clemson orange and purple. I thought that was really a cool image. And here's a poster that came out we're talking just after the game ended. And, I wanted to go down to Florida and be with y'all watching the game, but I was presenting at TRB, and so there's a bunch of Clemson students. This is Jennifer Ogle, my colleague. One of my PhD students, Kwaku, he is now a professor down at the Citadel, and we just had a great time. We took over the bar at our hotel, and we invited a bunch of folks, and we had a great party. And so this was a much more jovial party than 2016, at least after the game was over, when, of course, because in 2017 we won. This is my family. We need to be in Clemson orange, but this is and this is me. And so a little older than my picture that you saw earlier. My daughter at Auburn, and my sons, and my wife Sarah. And that's all I have. Thank you very much for your time.